Hi. I know a lot of you have had plenty of practice and you're probably pretty good at doing Gauss-Jordan elimination to get a matrix into reduced row echelon form, but some people are still kind of a little sketchy on it. So I want to walk you through an example of getting a matrix into reduced row echelon form. Okay. Um, some people are finding it not too difficult to get it into row echelon form, but then it's the last step, getting into reduced row echelon form, that is causing a little bit of confusion. So remember, reduced row echelon form means that once you get it into row echelon form and you look at the leading ones in each row, the leading ones need to be the only non-zero entry in that column. So there have to be just zeros above and below any leading one. So I'm going to walk you through an example because I haven't had time during lecture to actually go through all the steps. But I need you guys to be able to do it. So this is doing Gauss-Jordan elimination by hand, and this is a matrix I got from one of the exercises in 1.3. So it was a network analysis problem. It was we got a system of 4 equations and 4 variables, and then if we take the augmented matrix of that system, the matrix looks like this. So we start with the top row and look for the first entry in the top row. And we see that in this particular matrix, so I'm labeling my rows and my columns here. So in this particular matrix, I have a 1 in the first entry of the top row, which is perfect. That's called a leading 1, and that's what we want. However, in reduced row echelon form, we want that leading 1 to be the only non-zero entry in that column. So if we look below, we see that there's a non-zero entry there. So we use the leading ones to knock out all the other entries in the column. Okay, so I'm going to use the leading 1 in row 1 to knock out the other non-zero entry down in row 4. So what I'm going to do is I'm going to take row 4 minus row 1, and that's going to be my new row 4. So we have to do every entry, right? We can't just do the first entry. Every single entry has to have the same operation. So I'm going to recopy the first 3 rows of the matrix because those aren't going to change. The only changed row is going to be the fourth row. So the first entry in the 4th row is going to be 1 minus 1, which is 0. The second entry is going to be 0 minus negative 1, which will be positive 1. The third entry is going to be negative 1 minus 0, which is negative 1. And then the 4th entry is 0 minus 0, which is 0. And then the last entry is negative 100 minus 200, which is negative 300. So that's our new 4th row. And then we look and we see that that leading 1 in the first row is the only non-zero entry in that column, in column 1. So that row we're finished with. So then we move down to the second row, and we notice that there's a 1 in the second column, second row, the second entry of the second row, which is good. So that's a leading 1. And it's to the right of any leading ones above it, which is perfect. However, we want reduced row echelon form, so we need zeros above and below this leading 1. So let's look at the non-zero entry right above it. It's a negative 1, and if we want to make that a 0, we're going to use the leading 1 to knock it out. So if I add the leading 1 to that negative 1, it's going to be a 0. So let's add the second row to the first row to change the first row. So it's going to be row 1 plus row 2 is going to be our new row 1. So I'm going to recopy all the other rows, the rest of the matrix, And now I'm just going to change row 1. So the new row 1 is going to be, the first entry is going to be 1 minus 0, which is 1. The second entry is going to be negative 1. Sorry, that first entry was 1 plus 0. I wasn't subtracting, I'm adding. So the second entry is negative 1 plus 1, which gives me 0. The third entry is 0 plus 0, which is 0. The third entry is 0 plus negative 1, so I get a negative 1. And then the last entry is 200 plus negative 100, so that's positive 100. So now there's a 0 above my leading 1 in the second row. But if I look below the leading 1 in the second row, I still have another non-zero entry. I have that 1 down in row 4. So I'm going to knock out that 1 using the leading 1 in that column. So I'm going to take row 4, subtract row 2, and that'll be my new row 4. So I'm going to recopy the rest of the matrix. The only row that's going to change is row 4. So the first entry in row 4 is going to be 0 minus 1. 0 minus 0. Sorry. 0 minus 0 is 0. And then the second entry is 1 minus 1, which is 0. That was the one that we needed to knock out. Third entry is negative 1 minus 0, which is negative 1. Then we've got 0 minus negative 1, which gives me positive 1. And then negative 300 minus negative 100 is negative 200. So now the second row is good. That leading 1 in the second row is surrounded by zeros in that column. It's the only non-zero entry in the second column. So now we go down to row 3, move over 1 column. So we're now in row 3, column 3. And we see we have a leading 1 in the 3-3 entry, which is perfect. But we want that to be the only non-zero entry in that column. And we look above, we have all zeros above it. But below it, we have this negative 1. And so we need to knock out that negative 1. We can knock it out with the leading 1 in that column by just adding. So we're going to change the fourth row by adding row 3 to it. So that's going to be our new fourth row. So I'm going to rewrite all the other rows. The first 3 rows are not going to change. So those are the same. And now row 4 is going to be different. So row 4 is going to be row 4 plus row 3, right? So the first entry is 0 plus 0, which is 0. The second entry, 0 plus 0, which is 0. Third entry, negative 1 plus positive 1, and that gives me a 0. Then I've got positive 1 plus negative 1 is 0. And then negative 200 plus positive 200 is 0. So now I've got a row of zeros, which is okay, and it's already at the bottom of the matrix. Perfect. It's exactly where it's supposed to be. If it weren't, if we had a row of zeros somewhere else, all we do is swap the 2 rows to make sure we get the row of zeros at the bottom. And then we look at all of our leading 1s, and they're in the correct positions. Each of the non-zero rows has a leading 1, and for each leading 1, it's to the right of any leading 1 above it. So it's going down in a step-like fashion. That's the echelon part. And it's reduced row echelon because any leading 1 is the only non-zero entry in its column. So if you look at a leading 1, look above it and below it, and you should have all zeros above and below any leading one, and that's what we have. So we have our matrix now in reduced row echelon form, and I'll call it RREF. All right, so we were solving a system of equations, remember, and I had my variables were x1, x2, x3, x4, so each row corresponds to a new equation. So the first row is x1 minus x4 is equal to positive 100. The second row is x2 minus x4 equals negative 100. The third row, x3 minus x4 equals 200. And then the last row is 0 equals 0, which adds no information, so I'm just going to not write it. Now, each of these we can solve for the first variable in the equation. So the first one gives us x1 is equal to x4 plus 100. The second one gives me x2 equals x4 minus 100. The last one gives me x3 equals x4 plus 200. And now we can see that x4 is the free variable, and so we can replace it with a parameter, and we get the following solutions. x1 is t plus 100, x2 is t minus 100, x3 is t plus 200, and x4 is t, and we have to say where t is any real number. And I've used set notation, which you may or may not be familiar with, but that little symbol that kind of looks like a little E, that means element of or a member of. So t is a member of the real numbers, and that funny looking R is called blackboard boldface. So it's a notation we use for the real numbers. In a textbook, it would be boldface, but we can't write boldface when we're writing with a pen. So we use this funny boldface R. All right, so that's doing Gauss-Jordan elimination by hand. So remember to get a leading one in any non-zero row, and that leading one needs to be surrounded by zeros above and below it in its column. And always just keep in mind that you're using that leading one to knock out the other entries in its column. And if you want to, if you need to, if you don't have a leading one, but in the right place, but a row below it has a leading one in that column, just swap the rows. So I could have done some row swapping here and there. I could have done different operations in a different order, and I would have gotten the same answer as long as I'm using legal operations. So now, from now on in your homework, I don't want you to spend a lot of time on Gauss-Jordan elimination. I do want you to start using technology, because from now on, very soon, we're going to start doing problems where getting a matrix into reduced row echelon form is very important and necessary, but it's not the main point of the problem. We're really trying to do something much more higher order, and so I don't want you to waste a lot of time with, it's like wasting time with arithmetic when you can use a calculator. So I want you to start using technology. However, on an exam, you won't be able to use technology, but don't worry. When there is a problem requiring Gauss-Jordan elimination on an exam, I'm going to make sure it's a very simple procedure that takes a couple of steps and is not going to take a lot of your time. Okay? So, but I want you to know how to use technology on your homework so we can do more complicated problems and not spend a lot of time. So we're going to do the same thing, but we're going to use technology. If you go to our Canvas site, you'll see that I have a page that lists a bunch of graphing utilities and what they can do. Now, I got this table from our textbook, I believe that's where I got it. So a lot of you already own graphing calculators, like a TI-89, a TI-84, TI-83. That's fine. That's great. You can use that on your homework, not on a test. And if you don't own one, do not buy one because there's no reason to spend $100 for a calculator when there's a lot of free technology out there. But if you already own one, you can see that they can do a lot of things. Now, there's a lot of things on here you probably don't know what they mean, but you'll learn later in the course. But notice that all of those graphing calculators in this table can do elementary row operations. And they can actually, there's a way to just say reduced row echelon form, and you can enter the matrix. So if you already have one of these calculators, play around with it, look at the user manual. If you lost the user manual, just Google it, and you can find out how to use it to simplify your life when you're doing homework. If you don't own any of these, don't worry, there's a lot of free stuff on the web. So also on that page, on the Canvas page, I list a couple of websites that you can go to. And some of these also have phone apps. So Wolfram Alpha, the first one on this list, is my favorite. I use it all the time. And it also has an app. I have an app on my iPhone. The next one, GeoGebra, also really powerful, and it has a smartphone app. Now the app may not have all the features that the website does, but for our purposes, I think the app for these two, the apps work fine. Then sagemath.org is super powerful, but it's a lot harder to use. If you have time and you like figuring things out, that one you can use that too. And that one I don't think has an app. And then the last one is a website that some math professor created, and it's a pretty good one. It's got some tools that you can use. It also has a lot of examples, a lot of problems, practice problems you can do. It's a very helpful website. So I'm going to show you Wolfram Alpha, which is my favorite. So I'm going to get the same matrix into reduced row echelon form. And so when you're typing in Wolfram Alpha, when you're typing in a matrix, you're going to use this notation. So the matrix itself, the command I'm going to use is RREF, or you could just type in Gauss-Jordan Elimination. It's very intuitive. You type in the command that you want and then type in the matrix. So to type in a matrix, you're going to use curly bracket for the matrix, and then each row is going to be another set. So however many rows your matrix has, you're going to use curly brackets for each row, and then each entry in the row has to be separated. They have to be separated by commas. So the first row in this matrix is 1, -1, 0, 0, 200. So I had to list them in set notation with commas. Okay, so that's what I'm going to do. I'm going to show you the website. Whoops. Sorry. I'm moving the wrong thing. So I'm going to show you. Here's Wolfram Alpha. And I could type in RREF for reduced row echelon form, or I could just type in Gauss-Jordan Elimination, and then bracket, and then my first row, I have to use bracket again, 1, -1, 0, 0, 200, bracket. And then each row is separated with a comma. Second row is 0, 1, 0, -1, -100, bracket, comma, third row, 0, 0, 1, -1, -100. Oh, am I in the wrong row? Oh, sorry. 0, 0, 1, -1, and then 200, sorry. There it is. 1, 2, 3, 4, 5, yeah. Fourth row had to have a comma, a bracket, 1, comma, 0, comma, -1, comma, 0, comma, -100, bracket, bracket. And then I hit the equal sign. Let me make sure. I think I've got it right. Computing. Oh, please. Doesn't understand. Oh, maybe I should have put a comma for Gauss-Jordan. Let's try that. There it is. Okay. Gauss-Jordan has a hyphen. So did I get the same matrix? I believe I did. Yeah. So you can use this to check your answers. You can use this to do the row reduction for you, just so you don't waste any time, because it's a very mistake prone process. Notice that there's a little button for step-by-step solution. So if I click on that, it's actually not going to give me the step-by-step solution. It's going to tell me I can pay for it. So if you want to go pro, there's a student rate. I think it's about, let's see, I think it's about $5 a month. Here we go, $4.75 a month for students. The pro version for students. I have a pro version for teachers. So if you want to pay $5 a month, you can actually have it show you step-by-step solutions. So you can actually use this to learn. This is a very, very powerful website. You can use it for chemistry, physics, all kinds of things. And it's very intuitive. So if you don't know a command, just type in a word that you think the command should be called, and it'll give you some options or give you some examples, so you can browse examples here. So learn how to graph things. You can learn a bunch of calculus. So there's a lot of stuff here, and I encourage you to explore it. So if you have any questions about Gauss-Jordan elimination or reduced row echelon form, please let me know. I will help you out. I'll make some videos, or you can come talk to me in my office hours. Okay? So good luck, have a great weekend, and I'll see you guys next week.